So again, good morning to all. So in this video, we will discuss the concept of dynamic memory allocation. Okay. So let me explain to you what is the meaning of dynamic memory allocation. The requirement is I am going to request to the compiler, please allocate some memory at the time of running the program. Okay. So let me explain to you. So hash include malloc.h. So first of all, I have to include this header file and then let me apply main. Okay, like this. So what is the syntax of this? I have a function named as malloc. In this, you can pass the number of bytes which has been required. Let's say I pass number of bytes to 100. So what is the meaning of this one is? The meaning of this one is compiler will give me 100 bytes like this. Like this. So that is byte B, sorry, that is byte 1, byte 2, byte 3, byte 4, and so on by 100. So compiler has given me 100 bytes inside the memory, and I am going to use the base address of first byte to A. Are you following this? Let me explain again what is the meaning of this one is. First of all, inside the function, I have to pass the number of bytes has been required. So number of byte required is 100. So compiler will give me 100 byte block and the base address has been assigned to A. But at the same time, what can I do? I can request compiler that please divide 100 bytes to like 50 cross 4. It means 4 byte has been grouped together to form an integer like this. So that is called casting. What is the meaning of casting? The meaning of casting is I have available space and I am going to request to the compiler that please arrange the space according to the number, because we are dealing with the address we have to put star. That is called casting. The meaning of casting is compiler will allocate me the 100 bytes, but I want to group 4 bytes into 25 blocks. So what is the meaning of this one is it becomes 4 block, 4 block, 4 block 25 times. Are you following this? 25 times like this. Okay. Then I have assigned the base address to A. So what can I do? I can apply the loop for I equals 0, I less than 25, I plus plus. So please pay attention how we can put scanf percentile D, and what is the meaning of the first block? What is the first block? How we can refer to the first block? Let me remove address of first. So first block, the block name is A. The first block is A0. That is that. A0. Second block is A1 and so on. So what I can do? I can put A plus I. Please pay attention. So the value of I is 0 and the type of the address is int. So whenever you will put A, let's say the value of A is 100. So the base address is 100. So it becomes 100 plus 0. It means this block. So you are going to enter in this block. Okay. The moment value of I becomes 1, it becomes A plus 1. It becomes 100 plus 1. But we have seen that in a case of pointer, or in a case of address, this plus will indicate the block. And what is the size of block? The size of block is 4 bytes. So it becomes 104. So the second byte will be occupied. Are you following this one? So we have seen that in a case of pointer, or we can say address, the arithmetic operator will not perform arithmetic operations. It will jump to the block. So in this manner, at the runtime, what I can do that I can request some bytes to the compiler and I can use them. In a similar manner, I can print the things like 4, I equals 0, I less than 25, then I plus plus. And I have whenever we have a address with the help of star, I can print the value. So I can write P plus I. Are you following this one? So that is quite similar and quite simple. So in this program, what we have seen that malloc is a function that requires number of bytes. We have passed number of bytes, and at the same time we have requested to the compiler, please cast these bytes to the integer. So compiler has divided byte blocks. It means 25 blocks, and each block has 4 bytes. Then what we have done, then we have applied loop I equal to 0 to 25. We have put the values to the blocks, and at the later stage we have print the value. Okay, so it looks very simple. Okay, then let me explain the second program to you. Okay, let me rub this one. So let me show you how we can use malloc inside the structure. Okay, so first of all let me define structure. And in this structure, let's say I have 3 fields, int A, int B, and int C. So inside structure I have 3 fields, A, B, and C. Okay, so let me define main, void main, and let me define like int number. Okay, then struct. Okay, sorry for this. So what is the task? First of all, I will request to the compiler how many blocks are required. So I will write printf enter number of block. Okay, enter number of block. Now let me put scanf percentile d and number. So let's say user enter 20 block. Okay, so what is the meaning of this one is I have to take a block of 20 struct A. Okay, so how we can do that? First of all, let's include has, include malloc, and so on. Okay, please include the header files too. Okay, so how we can do that? Let me explain to you. First of all, I have to call a function named as malloc. So how many bytes are required? In the last case, we know the size of an integer, but in many cases, what is going to happen? We don't know the size of a structure. Okay, and sometimes what happens? In fact, we don't want to calculate the size of a structure. So what we can do in such cases? I can call a operator named as size of. In size of, you can pass anything. If you will pass int, it will give you 4 bytes. If you will pass char, it will give 1 byte. And if you will pass struct person, so probably it will give you 12 bytes. Okay, so to make the program dynamic, you are requesting the compiler, please calculate the size of struct person and how many blocks are required. So into number. So what is the meaning of this one is, let's say the size of operator gives you 12 bytes, and how many blocks usually required? So it will give you 120 bits. Are you following this one? Let me explain to again. In malloc function, what you have to pass? You have to pass number of bytes. So in order to calculate number of bytes, first of all you have to calculate the individual size block, and then how many blocks, that is number of block, and that is size of a block. Are you following this one? Then compiler has given you 120 bytes like this. But as we have seen in last program, we have to cast this one so that I can treat every block as structure. So that is called casting. How we can do that? We can cast that struct A star. So in the last case also we have done this, but in the last case we have type a block of type integer. Here we are going to perform typecasting with the type of struct A. And then let me store the address like struct A, B. So that is a complete line. So you have to focus on this line. Let me explain you again. First of all, you have to request to the compiler that we required some bytes. So I have used the malloc function. In malloc function, I have passed the size of struct person. So it will give me the size of individual block. And along with this, I have passed into number. It requires number of blocks. Okay. Then compiler will give me couple of bytes. At the same time, I have to request to the compiler, please cast these bytes so that I can treat every block as a structure. Okay. Let's say compiler is giving me 120 bytes. It might be possible it is 6 into 20. It can be 10 into 12. So I have to request to the compiler, please maintain this size like this one. Okay. So let me put scanf also. So we can apply loop for I equals 0, I less than number, I plus plus. And then let me put scanf percentile D, and what is the A? B is a base address. So let me explain. If B is a base address and we have 10 blocks like this, and every block we have 3 fields. So what I have to write? First of all, I have to write B plus I. So it will give me the base address. B plus 0 base address. Inside this one, I have a block named as A. Are you following this one? That is A. At the same time, we have to write B plus I. It means I am dealing with this block with a variable B. And we have seen several times, if I have a like this address of like this. If I have a base address of any block, I can access the element with a dot notation. Okay, and you have to check whether I have to put this one or this one. I'm not very sure whether you have to like put arrow or dot. Okay, so you have to check, but let me explain the concept. The concept is whenever you are going to call malloc, you have to pass number of bytes, and whenever you are going to pass number of bytes, what we can do, we can calculate the size of a block and number of block required, then you will get the base address. Okay, this one. And you have to cast at the same time. Whenever you have a base address, you can apply a loop, and we have already seen that in a case of address, this plus operator will not perform arithmetic operations. It will perform like jump into the block. Okay, so in this way I have accessed the block number A, block number B, and block number C. So in this program, we have seen that how we can use malloc and calloc with the help of structure. And at the same time, we have to check whether I will use dot or we will use arrow. So that is probably the homework for you, because whenever we have an address of any block, in the case of structure, we can use arrow also. So we will see in future what we will do. But the primary purpose of this video is to explain you malloc function. Okay. So thank you for all.